For several decades now, the relentless progression of Moore's law has enabled exponential improvement in area, performance, and power. This has led to hundreds of billion dollars of market capitalization in many semiconductor companies that have been created riding on the back of this relentless Moore's law progression. However, as we look ahead, we definitely see that the performance and power gains from Moore's law migrations are getting limited in the 15 to 30% range. The scaling continues unabated, and we still continue to see nearly 2x scaling from node to node, but performance and power are definitely not growing at the same trajectory as before. So we need to overcome this because of the relentless innovation that's happening in the semiconductor industry to drive this next level of improvement of performance and power. This is enabled by applying a booster pack to Moore's law, and it really comes from three specific concepts. First, the application of domain-specific architectures. This is truly called the golden age of computer architecture, as companies across the industry are rapidly looking at new architectures based on specific workloads and applications to boost the final performance and per watt of their final designs. Second, the advent of 3D IC designs and multi-die integration. The ability to bring multiple dies onto the same package and optimize system-level parameters like memory latency or die-to-die latency is definitely giving us a boost as well. Last but not least, the application of AI to EDA design and methodologies also gives us some nice gains in performance and power. So pulling these three things together, we basically apply a booster pack to the classic Moore's law, and we hope to get to the same type of gains as we have seen over the past couple of decades. At Synopsys, we term this phenomenon as SysMoore, and really this is the advent of the SysMoore era. In addition to everything we've seen around Moore's law, there is also the engineering cost that has to be considered. As we make node migrations from node to node, the total engineering cost in person months required to design SOCs at the latest node is growing significantly. So not only do we have a performance power challenge we need to overcome, we also have to overcome the fact that the total number of VLSI design engineers is definitely not growing at the same rate at which the engineering costs are increasing for some of these complex advanced node projects. So we have these twin challenges of performance power and engineering productivity that have to be overcome with EDA innovation.